All right, so what you did was actually varying directly. That's all we've done so far is what we did in the bell work, varying directly. We are going to start introducing different types of variation. And the first variation we're going to talk about is inverse variation, a function in the form of y equals k over x. And so if you look at the top of that page, they show you what inverse variation looks like. What you just did was direct. It looks like this, y equals k times x. And so remember, you don't have a plus or minus if it directly varies. It has to be able to be put in that form for direct variation. For indirect variation, it looks like this, y equals k over x. It inversely varies. So it says, suppose that x and y vary inversely, and x equals 3 when y equals negative 5. Write the function that models the inverse variation. So let's look what happens when you have something like this. Just like in direct variation, what you're trying to really find is that k, so that you can have an equation for all things that fit this model. And so for this, you're just going to plug in your x and y. Y is negative 5, x is 3. So how do I solve for k?
You just multiply 3.
Yeah, so k equals what? Right. So in inverse variation, your k is going to equal what? What do you think your k will always equal? Based on this, what will your k always equal? X times y. In direct variation, your k always equals what?
K equals y.
Yes, okay? And so this is one way you can start seeing, is this direct or is this inverse variation? What's happening with my x's and y's? What is the pattern? Once you find your k, really what they're looking for is the model. What is the model? That just means the function that would work for anything for that one. And it's just going to be plugging in that k. So we're going to say y equals negative 15 over x. This would be my model. Does this indirectly vary? Or does it have a relationship at all? All right. We basically compare the x and y and say, is there a pattern that's going on? And if so, what is it? And so when you look at the x and y, for comparing direct or indirect variation, you're really going to say, can I divide every x and y and get the same answer? Or can I multiply every x and y and get the same answer? If that's true, then you have a variation. If it's not, then you probably don't have one of these and you can't name the relationship. And so for this first one, we're going to look and say, okay, so my two things that I'm looking at, k can either equal, it's going to either equal y divided by x or y times x. This will be direct and this will be indirect. All right. And so if I take y and divide it by x on this first one, 1.5 divided by 0.5, 6 divided by 2, and 18 divided by 3, do I get the same answer? Yeah, what is it? 3. So this is what type of variation? Direct. This is a direct variation, and my k is 3. And so I could just from this chart say that this formula looks like this, y equals 3 times x, right? Does everybody see how that's working? Look at the next one. If I take this next one and I say y divided by x, y divided by x, and y divided by x, oh, I put my decimal in the wrong place, y divided by x, am I going to get the same thing? No, most definitely not. That's not going to happen. And so we know we can cancel out that it's definitely not a direct variation. All right, so let's look at multiplication. 12 times 0.2, 0.6 times 4, and 1.2 times 2. Does that work?
Yes.
Yeah, that's what?
All
That's all 2.4, which means this is indirect. My k is 2.4, and it's going to look like this. Y equals 2.4 over x. Everybody see how we're doing this? All right. And then the last one. So we're going to say y over x. Wait, automatic. Like, do I have to keep going? No, that's definitely not gonna work. All right, so I can definitely see that's not going to work. So then we'll multiply y times x. I did x times y, but whatever. We were good right up until that last one, right? 2, 2, and 1.5. So in this case, I can say no, this is not direct or indirect. So this is neither.
Isn't a dumb question? Is indirect and inverse the same thing?
Yes, inverse.
Okay.
Did I say, yeah, I mean, I guess I'm using those interchangeably.
On the test, will it be indirect?
Yeah, it's actually going to say inverse on the test too, but.
Okay.
All right, heart rates and lifespans of most mammals are inversely related. Inversely. Use the data to write a function that models this inverse variation. Use your function to estimate the average lifespan of a cat with a heart rate of 126 beats per minute. All right, now, they give you the lifespan in minutes. Inversely varies, should look like this. Heart rate in minutes, 1.5 million minutes. Heartbeats per minute. 158, 6.3, 76, 13.1, and 63, 15.7. So the slower your heart rate is, the longer you live, right? That is an inverse variation. You should see them going in opposite directions, right? That's inverse. If they were directly varying, you would see them going in the same direction, all right? And we're going to look at the graphs a little bit. I'm not going to make you graph it, but it gives you a pictorial image of what's happening. Is my x is getting larger for direct, my y is getting larger, right? For inverse, as my x is getting larger, my y is getting smaller, or vice versa, okay? And so because it is inversely related, that's what's happening. All right, so the first thing we have to do is we have to first figure out what our k is. And for this, we can just take one of them, and I don't know which one they did, and we can figure out what my k is. So we're going to take one of these to figure out k, and then we're going to use k to figure out the question that they've asked us, because they want us to do this. All right, and so if my x is my heart rate and my lifespan is my y, then I'm going to say my k is going to equal one of my y's, and we'll just take this first guy, 1,576,800, divided by 634 to get my k, right? That's how we're going to find it for inverse. Backwards multiplication. Take that and multiply by the 634. So what is that when you multiply that out? So they round it. So they actually round their k to 1 billion, and they put all the zeros in for us because they're nice. All right. So now to figure out this, all right, that's my x, right? They want me to figure out my y. Well, I'm going to take my x and plug it in to solve for y. Y equals my k, which is that guy, over my x. My x is the beats per minute. So I'm going to take this guy divided by 126. Approximately how many minutes will a cat live? I think they rounded to this 8 million. Right, so you're dividing by, there's 60 minutes in an hour, there's 24 hours in a day, there's 365 days in a year. There are not just two variations. There are lots of ways things can vary. We have talked about two of them. We've talked about direct, y equals kx, and we've talked about indirect, y equals k over x. You can have multiple variations, right? Y varies directly with the square of x. So this is key here, directly. But instead of varying directly with just x, with the square of x. So he's going to look like this, y equals k x squared. Y varies inversely, we know that term, with the cube of x. So whatever is first is what you're comparing it to. And then they're going to say this inversely or directly. The third word they could say is jointly. So then you have two variables that it does with. So look at these. Directly with the square, we have this. Indirectly with the cube, k over x cubed. Jointly with x and y. Z is going to be what's on the left-hand side, equals k times xy. So it's jointly varying. Z varies jointly with x and y and inversely with w. So that means kx and y will be on top, w will be on bottom. So jointly or directly tell you a numerator type thing. Inversely tells you what would go in the denominator, okay? Z varies directly with x, inversely with the product of w and y. So what does that tell me? That tells me x goes on top. You always have a k, by the way. And w and y go on bottom. So you have to start reading these because we're about to do a word problem, as you can imagine. And those words tell you how to set up your word problem and then plug in your variables and solve for whatever variable you are missing. All right? So let's look at this example here. Newton's law of universal. All right, Newton's law of universal gravitation is modeled by the formula F equals G m1 m2 over d squared. F is the gravitational force between two objects. M1 and M2 are the masses of those objects. D is the distance between the objects. G is the gravitational constant, aka we would call that K in all of our problems. It's a constant. It doesn't change. Gravity doesn't change. I mean, I guess it depends on where you are, but on Earth, gravity doesn't change, okay? Describe Newton's law as a combined variation. So they want us to verbally describe this law, okay? So how would we say that? We would say the force varies jointly. So it is direct, but because there's two of them, we're going to use the word jointly. We're going to say jointly with, and we'll just say mass 1 and mass 2. Mass 1 and mass 2. And what else do we need to say?
And inversely.
Yeah. Inversely with what?
With the direct.
With the square of d, right? So we don't have to mention G because that's the constant. So the constant, there's always assumed that there will be a constant in your problem, okay? You'll notice that in the examples above or in the list above, it never says anything about a constant, all right? Because there's always assumed that you can have a constant of variation, whether it be 1 or whether it be, in this case, the gravitational force, all right? So let's look at this geometry. They want you to describe the area of a trapezoid. They have given it to you. You don't have to remember it. But they want you to describe it. So think about what your constant would be in that and think about how to describe it. How did we describe this? They gave me the formula. They gave me this formula right here, okay? So if it is in the numerator, it's going to be either direct or joint, depending on if there's one or two variables. If it's in the denominator, it's going to be inverse, all right? They told us what all of those variables mean. So that's how I came up with the words for it. All right. So I know that force is going to vary directly with both my M1 and my M2. All right. With both of those. So I could probably say varies directly with the product if I want to say it that way. Or I could just say varies jointly, whichever one. But we have to say it varies with both the M1 and the M2. What does it mean by that? Well, if M1 changes, my force is going to change, right? If M2 changes, my force will change. If M1 or M2 go up, what will happen to my force? My force will go up. Why? Because it's in the numerator. Let's think about this logically. If I have something varying directly with something, it means it's not being divided by it. It's being multiplied by it, okay? Right? So if I have, let's use a basic area formula here, all right? Let's use a basic area formula. Area equals base times height. Okay? That's the area of a rectangle, right? That's an easy one, okay? So I have this random rectangle here, okay? If my base increases, what's going to happen to my area? My area will increase. If my height increases, what's going to happen to my area? My area will increase, right? Because my area is directly related to how wide and how tall this is. That's what direct means. It is directly related to that. But what happens when you throw something in the denominator? Not that I have an area formula with a denominator with a variable, but so let's say I have some random formula, which they gave us. They gave us this force formula. So now all of a sudden, the mass 1 and mass 2 look very much like base and height, don't they? They're being multiplied. So if my mass 1 and mass 2 increase, my force is going to increase. That only makes sense, right? But then I throw this guy in the denominator. So now whatever's happening to my mass 1 and mass 2 is being divided by that d, the distance between the two, okay? Right? So now, assume my mass 1 and mass 2 are established, okay? What happens if the d increases? Is my force going to go up or down if my denominator increases? It's going to go down. I am dividing by a bigger number. If it is 2, it's going to be a bigger number than if it's 4. If I take a number and divide by 2, that's going to be bigger than if I take the same number and divide it by 4. That's only logical, right? So when my inverse variation happens, whatever's in the denominator inversely affects what's over here on the equal sign. Inversely. Meaning if that denominator gets bigger, whatever's on the other side of the equal sign is going to get smaller because I am dividing by a bigger number, okay? In this particular thing, I have 2 objects, all right? I have, 2 planets, whatever, the gravitational force between those, okay? If those are closer, the distance is smaller, you're going to see the force stronger than if they're further apart, all right? So now they're telling us what's happening. The volume of a regular tetrahedron varies directly as the cube of the length of an edge. The volume of the regular tetrahedron with the edge length of 3 is 9 square root of 2 over 4. Find the formula for the volume of a regular tetrahedron. There we go. All right, so a couple of things we want to look at here. Varies directly, all right? So volume is going to be what we set out by itself, volume. And then we're going to look at this word, varies directly. It varies directly with what? With what? The cube of the length. Okay, so we'll assign L as the length. And we know that it's going to be L cubed. We have one more thing that we have to account for. What's that? Our K. So we actually don't know the K. That's what we need to know, okay? They have told us the volume of a regular tetrahedron with the edge length of 3. What did they give us? Edge length of 3. Which variable did they give us? L or V? Yeah, they gave us L. So edge length of 3 is 9 square root of 2 over 4. What is that? That's my V. So I do not know my K. Substitute it in, right? Find the formula. 3 cubed is what? 27. I'm going to do what with that 27? To solve. It's K times divide. So 9 square root of 2 over 4. By the way, if you divide, you can just put him down here. All right. Before you multiply, reduce. Before you multiply your 4 and your 27, what can I reduce that with? On top. What can I reduce on top? 9. 9 goes into 27 how many times? 3 times. It does go in once, but 2 more. Square root of 2 over 12 is my K. All right? So what's the formula then? What does it look like? Well, volume of a tetrahedron is square root of 2 over 12 L cubed.